Hello everyone, I hope you are doing well. In this video, we'll see how to draw planes from given Miller indices. Now, here the Miller indices are of all kind. The sets are of all kinds. For example, the planes with all positive Miller indices, the planes with one of the index as negative. Okay, as you can see here the x index is negative, y index is negative, and here the z index is negative. In a case where two of the indices are negative, we can see here the x and z index is negative. The method will be clear. So I'll see that if I will do another problem with, let's say, two like that. Okay, so with x index negative and y index negative, so that the number 1 is not there, only the other numbers are also there. So I'll do that also in a case with all of the Miller indices negative. So this video will completely cover all kind of problems. Okay, and the method that I will display here can be used for any kind of Miller indices set that is given to you. Okay, so first of all, we'll do for the all positive case, which is 0, 1 and 2. The video on how to find the Miller indices of planes is also uploaded in English version as well as in Urdu and Hindi version. So you can check out the playlist. I have separately made the playlist for the English version videos and also for the Urdu version videos. So you can check it out in playlist section. It will be more helpful to you to go there and get your desired video. I have also uploaded a video where we have drawn the directions from the given Miller indices that includes all kind of cases, and the method that I illustrated here is very simple and can be used for any kind of set that is given to you, and it will help you to have a better understanding of solving the problem. That will help you to solve the problem. So here the first one is 0, 1, 2. Okay, the Miller indices are given 0, 1 and 2. And first of all, what you have to do is to draw a cube. If you have pens of different colors, then it will be better, because you know, in 3D diagrams and in drawing the planes in directions, if the different colors are used to do different kinds of components inside a diagram, then you can easily distinguish different components. Otherwise you will mix all of the lines. So whenever all of the indices are positive, that case will be referred to as all positive case. Okay, whenever I'll say all positive case, then it means a case when all of the Miller indices are positive. So when all of the Miller indices are positive, then you will always take that one point as origin. Okay, so if the one of the index is negative, or two of the index is negative, or three of the index is negative, you will have to shift the origin. The position of the origin is always selected such that the plane that we want to draw will lie in a single unit cell. Okay, and if you do not shift the origin, then the process of drawing a plane will become complicated, as multiple unit cells will be required to draw the plane. Okay, so we don't want to complicate the process, and we want to draw the plane in a single unit cell, and for that purpose you have to shift the origin whenever the indices becomes negative. And I'll show the process step by step. Okay, so first of all, let us do it for the all positive case. And for all positive case, this is the all positive origin. I'll call it as all positive origin. So this is the origin, and let us call this line as x-axis. Okay, and this line as y-axis, and this line as the z-axis. In drawing the planes and in finding out the Miller indices for the planes also, the axis lines are very important. Okay, because we are interested in intercepts, and intercepts are the point where the plane cuts the axis line. Okay, so this will give us the x-intercept. This will correspondingly help us to find out the y-intercept, and this one will give us the z-intercept. So what we have to do is to find out the intercept, and to find out the intercepts of the plane 0, 1, 2, we will take inverse of each of the index. Okay, we'll take the inverse of each of the index. So, the indices are 0, 1 and 2. Okay, taking inverse will give us an intercept. So taking inverse of 0 will give us infinity, taking inverse of 1 will give us 1 again, and taking inverse of 2 will give us 1 by 2. All right, so this is the x-intercept, and this is y-intercept, and this is the z-intercept. Okay, so first of all, we'll focus on the intercepts which are not infinity. Okay, the infinity cases are considered at the end, okay, at last. So first of all, the y-intercept is 1, which means from origin to the other corner of the unit cell along the y direction, which is this one point. So this is the y-intercept, and let us make it prominent, okay, with some other ball pointer making a very big dot so that it shows that it is one of the point on the plane. Okay, this is the y-intercept. I have drawn that point. Now the other intercept is z-intercept, which is half, so from origin again. Okay, in drawing the intercepts, you always move starting from origin, while in case of directions you move onwards from the point you left. Okay, so from origin again, half unit along the z-axis, this whole length from one corner to the other corner of the unit cell is 1, and half of it is about here. So this is the other point on the plane. All right, now next thing is x-intercept is infinity. So x-intercept is infinity. How we'll deal with that is we will draw a parallel line from each of these 2 points that we have found for the plane. Okay, parallel lines from this these points along the x direction. Okay, parallel to x direction, we'll draw parallel lines from this point. So let us draw the parallel lines. The direction is here. Okay, so from this point parallel to x-axis is this point to the other corner of the unit cell. Okay, you will stop to the other corner of the unit cell, which is now this point. Okay, and again also from this point we will draw parallel line along the x direction, which is this direction, and up to there. Okay, next on we have to join these 4 points together to form a closed figure. So we'll join these 2 points together and these 2 points together, and okay, and this is the plane 0 1 2. Shade it like that. Okay, so this is the plane 0 1 2. All right, so this is example that I am going to show you people, because sometimes students get confused when this one plane comes in, because if we take the inverse of these 3 Miller indices in order to get the intercepts for the plane, then you get 2 infinities and 1 as one of the intercepts. So how you will draw this plane? Okay, so we have a cube first. Okay, we will first draw the cube. Since all of the Miller indices are positive, so we'll take this point as origin. Okay, this is the x direction, this is the y direction, and this is the z direction. All right, so to find out the intercepts, of the plane 1 0 0, will take the inverse of each of the index. You will write it yourself, and these are the 3 indices. We'll write the operation that we are going to perform on these indices, that is taking inverse, and inverse of 1 is 1, inverse of 0 is infinity, inverse of 0 is infinity again. So this is the x prime intercept, this is the y prime intercept, and this is the z prime intercept. It's because when you are finding the Miller indices of a plane, you take the inverse of the original intercepts that are found for the plane. So in order to find out the intercepts from the Miller indices, you will reverse the process, which is to take the inverse again. Okay, so this is the x prime intercept, y prime is infinity, and z prime is infinity again. And we deal with infinities at the end. First of all, we'll draw the intercept which is not infinity. Okay, so that is the x prime intercept, and if it would have been y prime intercept, like for that one case, then you will draw the y prime intercept first, because corresponding to that you will get a non-infinity result, while for the other two you will get the infinity. So infinities are dealt at the end, and we'll deal with the ones which are not infinity first. Okay, so that's x prime intercept, which is 1. So x prime intercept means from origin 1 unit along the x direction, which means to the other corner of the unit cell, which is this point. Okay, this is one of the point on the plane. Now we have got this point, and by using this point we can draw the whole plane along with this information. Now the y prime intercept is infinity. So what you have to do is to draw the parallel lines from this point. Okay, from this point along the y direction, positive y direction. Okay, so from this point we'll draw the parallel line along the y direction, which is this direction, to the other corner of the unit cell, up to the other corner of the unit cell. Okay, now this is another point on the plane. After that, since the z-intercept is infinity, from these 2 points you will draw parallel lines along the positive z direction, which is like that. Okay, ending to the other corner of the unit cell, and also like that. Okay, and we'll join these 2 lines, these 2 points together in order to form a closed figure of a plane. And here we go, this is the plane 100. All right, and this is the front wall of the cube. All right, and I hope you got the method. Now we'll get to know the method for the negative Miller indices. Problem here, the x index is negative 2 bar 1 2. Okay, it's bar over 2 because it's black pencil, maybe it's not quite visible, but it's 2 bar 1 2. These are the Miller indices of the plane that we are going to draw, and the x index is negative, so the origin shifting is required here. The rule is very simple, and it will be applicable to all kind of planes you are drawing. Okay, even if it is the Miller indices of a direction, and if they are negative, then the rule for origin shifting that we use here is used there too, for origin shifting while drawing the directions. Okay, I will display the rule step by step, and you will understand it by watching the problems. You cannot at first understand it completely. So let me first draw the cube. While drawing the planes in a cube, try to keep all these lengths equal to each other. Okay, if they are not equal to each other, and one of them is shorter and the other one is quite longer, then the shape of the plane will not come accurately. Okay, and the issue will arise. And in other cases, when the Miller index is not 0, the issue can arise. Okay, so this is one of the tips that you should keep in mind in drawing the directions. That's not quite important. If the shape of the cube, the lengths are equal to each other or not, the issue doesn't arise there, but the issue will arise in case of the drawing of plane. Okay, so yeah. Now first of all, this was the all positive origin. Let me call it as O. Okay, and since the x index is negative, what you have to do is to shift the origin by 1 unit along the x direction, because the x index was negative. Okay, whenever the x index is negative, regardless of this numerical value, okay, this numerical value doesn't hold anything in deciding the position of the origin. Okay, if it has been 7 bar, 1 bar, or 3 bar, or 2 bar, or whatever the value is, that doesn't matter. It's x index and it is negative, that matters only. Okay, so whenever the index is negative, you have to shift the origin starting from the all positive origin by 1 unit along that direction, which is having a negative Miller index. Okay, if 2 of the indices are negative, what you have to do is starting from the origin, you will shift the origin by 1 unit along one direction. Then from that point onwards, okay, continuing from that point onwards, you have to shift the origin one more time along that direction. For example, if x and y index would have been negative, then I will shift the origin from that point along the x direction there, then along the y direction by 1 unit there. So that one point would have been the final origin. Okay, if the y index and the x index, both of them would have been negative. So the process continues depending upon which one of the indices are negative. Okay, so the process will be more clear to you when we'll solve the other problems. Okay, so first of all, the x index is negative, so we'll shift the origin starting from all positive origin by 1 unit along the x direction, which is this point. Okay, since the other indices are positive, that is why no more shifting is required, and this is the final origin that we will use to draw that plane. So let me designate the axis lines, because axis lines are very important. We have to draw the intercepts, and intercepts are the points on the axis lines, not any other lines, but axis line. So this one line joining that is connecting the origin is the positive y-axis, y prime axis, since the origin is O prime, and we'll use a primed symbol. So this one is the negative x prime axis, since the x index was negative. Okay, and this is the positive z prime axis. Okay, the lines that are connected to the origin are the axis lines, and we have designated their names. All right, after deciding the position of origin, we need to find out the intercepts of the plane. Now, to find out the intercepts of the plane, to bar 1, 2, we have to take inverse of each of the index, because in finding out the Miller indices of the planes, we take the inverse of original intercepts of the plane. Okay, so to find out the plane from Miller indices, we have to do the reverse process, which is to take the inverse of the Miller indices again to get the intercepts. So these are the intercepts: -2, 1 and 2. The operation to be performed is taking inverse, and inverse of -2 is -1/2, inverse of 1 is again 1, inverse of 2 is 1/2. Okay, so these are the intercept. This is x prime intercept, because the origin that we will use to draw the plane is primed. That is why we are using primed names here. So this is the y prime intercept, and this is the z prime intercept. All right, so the x prime intercept is -1/2, which means from origin along this direction, 1 means from one corner to the other corner of the unit cell, half of it is like there. Okay, it's -1/2 here, and 1 along y prime direction. So starting from origin again, not from this point onwards, it's intercepts, and they're always drawn on the axis lines. From origin, 1 unit along the y direction, which is this point. So this is another point on the plane. Okay, and the next one is the half unit along the z direction, and starting from origin again, here somewhere like there, it's the point on origin. Okay, now we'll join the three points together to get the plane. Okay, joining these two lines together by straight lines. Yeah, something like that. Okay, a triangular type of shape, and shading it, this was the plane. Okay, and the more accurate your cube shape is, the more beautiful plane shape you will get. Okay, so that is the plane 2 bar 1 2. All right, so next problem is when the y index is negative, and that one case is 3 1 bar 3. Okay, let us do that one now. So here's the next problem. Okay, it's 3 1 bar 3. The y index is negative, and let me draw a nice little cube. Okay, so the all positive origin is this one point. That's the all positive origin. Now the y index is negative, and you have to shift the origin from all positive point to the other corner of the unit cell along the y direction, since the y index is negative. So we'll shift it along this direction to the other corner of the unit cell, which is this point. Okay, so this is the new origin O prime that we will be using to draw the plane. Okay, so this is a new region, and this is one of the line connecting to the origin point. This is another line, and this is the third line. This is the z prime axis, positive z prime axis. This is positive y sorry x prime axis. This is positive x prime axis, and this is negative y prime axis, since the y index was negative. Okay, so now we'll take the inverse. Okay, you have to write the same thing that I wrote for the previous problems when you are like solving it for exam. So we'll take the inverse of the Miller indices in order to find out the intercepts of the plane. So inverse of 3 is 1 by 3, inverse of -1 is again -1, inverse of 3 is 1 by 3. So this is the x prime intercept, this is y prime intercept, and this is the z prime intercept. Okay, so x prime intercept is 1 by 3. So from origin, new origin, 1 by 3 is the x-intercept. So we'll divide this whole length from one corner to the other corner of the unit cell is 1, and we'll divide it into 3 equal parts to get the 1/3 part. So this is roughly that. Okay, and this is the 1/3 part. So this is one of the point on the plane, this one. Okay, next is -1 intercept for the y direction. So from origin, new origin. Okay, this is the new origin. Again, starting from the origin, 1 unit along y direction, which is this -1. Okay, so this is the another point on the plane. This one point and these 2 points are the points on the plane. Now the third one is 1 by 3 along the z direction. So this whole length from one corner to the other corner of the unit cell, starting from the origin. Okay, you always draw these points on the axis lines, and they are always drawn starting from the origin. Okay, so starting from origin, we'll divide this whole length into 3 equal parts, and this is the point 1 by 3. Okay, this one, and this one. These 3 are points are the points on the plane, and we'll join these 3 points together in order to get the plane whose Miller indices is 3, 1 bar 3. Okay, so we'll join these 3 points together by straight lines, and here we go. Oh. Okay, it's on this point. We'll shade it, okay, with the same color, and yeah, that's the plane 3, 1 bar 3. Okay, that's done. Here's the next problem. Here the z index is negative. Okay, and first of all, we'll draw the cube. Okay, here's a small little cube, because all of the lengths are 1, so that is why the small cube will suffice. And this is the all positive origin. Okay, and you have to shift the origin because the z index is negative, and since the z index is negative, that is why we have to shift the origin from all positive point by 1 unit along the z direction. So this is all positive origin point, and 1 unit means to the other corner of the unit cell along the z direction, which is this point. So since the other 2 indices are not negative, that is why this is the final origin. Okay, and this origin will be used to draw the plane. Okay, and the axis lines are, this one line is the negative z prime axis. Okay, since the z index was negative, and this is the positive x prime axis. Okay, since the origin is primed, that is why we are using primed word, and this is the y prime axis, positive y prime axis. And now we need to find out the intercepts of the plane. So to find out the intercepts of the plane, plane 1, 0, 1 bar, we have to take the inverse of each of the index. So you have to write it right there. Okay, now we'll take the inverse of each of the index, and these are the 3 indices, 1, 0, -1. So taking inverse of 1 is 1, inverse of 0 is infinity, inverse of -1 is -1 again. So we deal with the infinity intercept at the end, and first we'll consider the ones which are not infinity. This is the x prime intercept, this is y prime intercept, and this is the z prime intercept. Okay, so x prime intercept is 1. So starting from the origin, from the new origin that we have selected, 1 unit along the x direction. Okay, since the x intercept is 1, so the point 1 is to the other corner of the unit cell along the x direction, which is this point. So this is one of the point on the plane. All right, so the next is the z prime intercept, which is -1. So starting from the origin again, okay, not from that point onward, starting from origin all again, because intercept is a point on the axis line. Okay, that is starting from origin, you will get that point. So it's -1, which means to the other corner of the unit cell along the negative z direction, which is this point. Okay, so this is another point on the plane. All right, since the y intercept is infinity, so we'll deal with that by drawing a parallel line from each of these 2 points that we have got, okay, for the plane, along the y direction. So from this point we'll draw the parallel line along the y direction, and this parallel line will end up to the other corner of the unit cell. Okay, so this is the y direction, and we'll draw parallel line along the y direction, which is starting from this point that we have got from these intercepts. Okay, these 2 intercept points. So parallel lines along the y direction will stop to the other corner of the unit cell here. Okay, this is another point on the plane now. Okay, so this is another point on the plane, and we'll draw parallel lines along the y direction, which is along this line. Okay, and we'll end up at the other corner of the unit cell, which is this point. Now these 4 points are the points of the plane, and we will join these lines together, this line with this one. Okay, and we'll shade these. This is the plane 1 0 1 bar. All right, this is the plane 1 0 1 bar. Okay, this is done now, and now we'll do the case when 2 of the indices are negative. Here comes the next problem. It's 1 bar 1 1 bar, x and z indices are negative. Okay, so let me draw the cube first. It all starts with a all positive origin, which is this point. This is the all positive origin that cannot be used for drawing this plane. Okay, we want to draw this plane inside a single unit cell, and for that purpose we have to shift the origin, and x index is negative. So first of all, starting from the all positive origin, we'll move 1 unit along the x direction, which is this point. Okay, regardless of this numerical value, it could have been 2 bar 3 bar or whatever it is, we always move 1 unit along that direction, which is having a negative Miller index. Okay, so from origin 1 unit along the x direction, and this could not be the final origin point because the z index is also negative. So from this point onwards we have to shift the origin 1 unit along the z direction, since that one has the negative index. So that one point is the final origin because the y index is positive and no more shifting is required along the y direction. So this is the final origin. Okay, and this is a new origin that will be used to draw this plane. And let us now draw the parallel draw the axis lines, and they are the 3 lines that are joining this point, and these are the 3 lines. Okay, and these lines joining that origin point are the axis lines. So this one line is the negative x prime axis. Okay, this one line is positive y axis, y prime axis, and this one line downward is z prime axis. Okay, so negative z prime axis. Now next what we have to do is to draw the intercepts, and to find out the intercepts, you have to write this line either here or here. Okay, I'm writing it here because I have some vacant space right there, and I want to make use of all the space. To find out the intercept of plane 1 bar 1 1 bar, we have to take the inverse of each of the index. You will write it. Okay, so after that write these Miller indices here, write the operation that you are going to process, that you are going to do, that is taking inverse. Okay, we'll take the inverse of -1, which is -1 again, taking inverse of 1, which is 1 again, taking inverse of -1, which is -1 again. Okay, so this is the x prime intercept, this is the y prime intercept, and this is the z prime intercept. Okay, these are the intercepts and they are drawn on the axis lines. Okay, intercepts are the points on the axis lines and these are the axis lines. Okay, so x prime intercept is -1. Okay, so starting from this new region, x prime intercept is -1, means to the other corner of the unit cell along the negative x direction, which is this point, this one pretty little point. Now next intercept is y prime intercept, starting from origin again. Okay, all over again and along y prime direction to the other corner of the unit cell, which is this point, another point on the plane. And starting from origin again, z intercept is -1, which means to the other corner of the unit cell along the negative x direction or negative z direction, and this is this one, negative z prime direction, and this is another point on the plane, this one, and this one. These are the 3 points on the plane. Now we'll join these 3 lines, these 3 points together like that. Okay, and this pizza slice is our plane, and if you want then you can eat it also. Alright, so this is done. Here is the next problem. Here the 2 of the indices are negative, which are the x and the y index. So we'll do that one problem also, and after that we'll do the all negative Miller indices case. Okay, so this is our cute little cube. Okay, and I doubt that it will create a problem because it's very little. So yeah, this is the origin. Alright, and we have to shift the origin. Okay, the x index is negative and the y index is negative, so starting from the all positive origin we have to shift the origin 1 unit along the x direction, since the x index was negative. Okay, and that shifting is always done by 1 unit. Okay, regardless of this numerical values that is there, these numerical values doesn't affect the position of origin that we select. Okay, the shifting of origin is always done by 1 unit. Okay, regardless of this value, the negative nature only matters. So from this point to the other corner of the unit cell along the x direction, we have shifted the origin. Now this is not the final origin point because the y index is also negative, so we have to shift the origin onwards from this point along the y direction by 1 unit, which is this point. Okay, so this is the final point, final origin O prime that we'll be using to draw this plane. Okay, so this is the final origin, and let us draw the axis lines because axis lines are very important in drawing the planes, and because we are given with the intercepts, and intercepts are the points on the axis lines. This is negative y prime axis. Okay, this is the negative x prime axis, and this is the positive z prime axis, since the z index was positive. So to find the intercepts of 2 bar, 1 bar, 2, we have to take the inverse of each of the index. You will write it right there, and these are the 3 indices. Write the operation that you are going to perform on them, which is taking inverse. Taking inverse of -2 gives -1/2, taking inverse of -1 gives -1, taking inverse of 2 gives 1/2. This is the x prime intercept, this is y prime intercept, and this is the z prime intercept. These are the intercepts. So x prime intercept is -1/2, so this is the origin, new origin, and -1/2 means this whole length is 1. Okay, from one corner to the other corner is 1, and half of it is right there. Okay, this is one of the point on the plane. Next is y intercept, which is 1 here. Okay, so -1 here. So from origin 1 unit means to the other corner of the unit cell along the negative y prime direction, which is this point. This is another point on the p lane, and z prime intercept is 1/2, which means from origin all over again 1 by 2 unit, which means the half of it maybe right there, like there. Okay, which is this. Okay, now we'll join these 3 lines together to get our cute little plane, which is obtained like that. Okay, so yeah, this is the plane 2 bar 1 bar 2. Okay, and yeah, this is done now. So here's the last problem that we are going to do. Okay, so yeah, this is all negative case, and let us draw the cube first and then we'll shift the origin. Okay, okay, so this is the cube, and please cooperate with me with the background voices because these are my family members, and they like to speak when I'm making video, you know, so I can't do anything of them. I have told them to stay silent, but they can't. Okay, yeah, so this is the all positive origin. Let us call it with O. Okay, let us call it O. And since the x index is negative, we have to shift the origin 1 unit along the x direction, which is this point. Now this cannot be the final origin point because the y index is also negative, so from this point onwards we have to shift the origin along the positive y direction, which is this direction. Okay, to the other corner of the unit cell here. And since the z index is also negative, you have to shift the origin onwards from this point along the positive z direction, which is this, to the other corner of the unit cell, which is this one point. So this is the final origin O prime. Okay, and the axis lines are these 3 lines connecting the origin O prime. Okay, this is negative z prime axis, this is negative x prime axis, and this is the negative y prime axis. All right, so to find out the intercepts of p lane 2 bar 1 bar 2 bar, we have to take the inverse of each of the intercepts. So it's -2, -1, and -2. Inverse of -2 is -1 by 2. It's -1, it's -1 by 2 for z intercept, and this is the x prime intercept, this is the y prime intercept, and this is the z prime intercept. Okay, now let us draw the plane using these intercepts. So it's -1 by 2 as x prime intercept. So from this origin, half unit along the negative x direction, which is this point. Okay, and -1 along the y prime direction, which is from origin, starting from origin as this point, the other corner of the unit cell. All right, and -1 by 2 along the z prime. So from origin, this is the half unit along the negative z direction. This whole length is 1, half of it is here, so here. Now let us join these 3 points together to get the plane, and yeah, that's our plane. That's our plan, and yeah, it's done now. Okay, I hope you got the method, and if you have any queries, if you have any confusions, you can ask me in comment section, and like, share and subscribe, and share it with your fellows, with everyone who can take benefit of that channel, because it has a lot of potential to help all of you guys. So yeah, goodbye.